Hello, my name is Curtis Taylor, and I'm a student at Wake Technical Community College. And I am currently in Biology 110, section number 4238. And this is my final project for this semester. My project today is entitled The Electron Transport Chain, A Day in the Life of an Excited Electron. The process that we're talking about today takes place in the chloroplast of the leaf of a plant, and it's also a process that is known as photosynthesis. But this is a particular aspect of that photosystem called the electron transport chain. In their normal state, electrons are bored. There's not much activity and no excitement whatsoever. But if you can introduce some sunlight to the equation, things can change drastically. The energy from the rays of the sunlight can make an electron become excited. Doesn't that electron look pretty excited to you? So now, our excited electron, he begins to jump for joy. He is so happy. He's just all over the place. In fact, he's so excited that he just can't keep all the excitement to himself. So he passes this energy from one electron to another electron to another electron until an excited electron is captured by the primary electron acceptor. This primary electron acceptor is what introduces our excited electron into the electron transport chain. But to keep all things good and in homeostasis, we have to replace our excited electron back there on that chloroplast. And the way that's done is through the splitting of water molecules. H2O is split, releasing hydrogen ions, and also it releases oxygen out into the atmosphere. And this is what allows you and I to breathe oxygen on a daily basis. And this is the way that the electron gets replaced. So back to our excited electron. Now he's going to be passed through a series of proton pumps. Now these pumps, they work hard. And what they do for energy is they use just a little bit of energy from the electron every time he passes through a pump. The energy that's used by the pumps is used to pump hydrogen ions from the stroma, which I guess we could consider or compare to the cytoplasm of a cell. The ions in the stroma are pumped back into the thylakoid and packed into this tiny space. Now what this does, this action creates a new gradient for the ions. And through a process called diffusion, these ions desperately and naturally want to move from an area of high concentration back to an area of low concentration. Now, if you think about placing your thumb on a water hose and how that creates a pressure and makes the water rush out stronger and faster, the same principle applies here. As that gradient builds, the ions rush back into the stroma with great force through diffusion. Now, the energy created in this force is used by ATP synthase, which uses that energy to bond a third phosphate to the molecule ADP. This chemical reaction creates ATP, the ultimate energy molecule. ATP is the fuel that keeps most living organisms running. So, just to recap, The light energy from the sun, it hits the leaf of the plant. It excites an electron on the chloroplast. This excited electron is accepted by the primary electron acceptor and introduced into the electron transport chain. Meanwhile, the water splitting system replaces that electron and releases oxygen back into the atmosphere as a byproduct. While in the electron transport chain, the excited electron is passed through a series of proton pumps, which pump charged ions from the stroma into the thylakoid, which creates a gradient. That gradient builds and builds until the pressure gets too much and the ions are released back into the stroma with great force. That energy is used by ATP synthase to attach another phosphate to ADP, which creates ATP. Our excited electron is not quite finished yet, though. He is then passed into a whole nother electron transport chain, the second electron transport chain. And this transport chain produces NADPH. Our excited electron is transferred into NADP+, which creates NADPH, which is a high energy electron carrier. NADPH and ATP are now used to produce sugar in what is called the Calvin cycle. So, as I'm sure you would all agree, our excited electron is truly, truly the superhero of energy production. Thank you.